This is section 1.6, two-dimensional figures. Our objectives are to identify and name polygons and find perimeter and area of 2D figures. So first let's talk about what is a polygon. A polygon is a closed figure with at least 3 sides that are all segments. Sides intersect only at vertices, and it's a plane figure, which means it's not 3D. Since we're talking about two-dimensional figures, it has to be 2D, like a piece of paper, flat. So here we have a pentagon. It's a closed figure. There's no openings. It has more than 3 sides, and all of the sides meet at vertices, and it's also 2D. And this is actually called a pentagon because it has 5 sides, but we'll talk more about that later. Over here on the right, the green figure is also another example of a 2D figure. So here are a couple examples, and we're going to decide whether or not these figures are polygons. The first one is a polygon. It's just like the example we saw on the previous slide. The next one is not a polygon because it's a 3D figure. The lightning bolt in the middle, this is a polygon. It's a closed figure, has more than 3 sides. All the sides are meeting at vertices. It's just not a typical figure that you would see. The next one is not a polygon because it's not closed. There's an opening right here. And finally, the last one is actually not a polygon because the sides intersect between the endpoints. So these sides right here are not intersecting at vertices. Now you could consider this 2 separate polygons, but the whole figure itself is not a polygon. To name a polygon, you're going to start at any vertex and list all the vertices in order. So if we were looking at this polygon down at the bottom, you're just going to pick a vertex and then you're going to name all of the vertices that come after that starting vertex. So this one I'm going to call polygon A, F, D, C, E, B. You stop whenever you get back to your initial starting point. Here's another example. There's numerous ways you can name it. You can start at any vertice. So I could do polygon HTAM. I could do polygon TAMH. I could do polygon MATH. You just have to start at a vertice and then continue to go in the same direction around the polygon. Now let's talk about how to classify a polygon. The first way we're going to classify it is deciding whether the polygon is convex or concave. A convex polygon is going to have diagonals that are inside the figure. So here's an example of a convex polygon. Notice that if I was to draw in diagonals connecting my vertices, all of the diagonals would fall inside of the figure. A concave polygon is going to have at least one diagonal outside of the figure. The easiest way to remember concave is it's going to be a figure that caves in. So notice it caves in right here, 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 and here. And as far as the diagonals, if I try to draw in a diagonal connecting these 2 vertices, it would be on the outside of the figure. The second way we're going to classify a polygon is by the number of sides. Many of these will look familiar to you. You've seen them before. A couple of them will be brand new. We are only going to name up to 12 sides, omitting 11 sides. We don't have a name for that. And then I'm going to give you a generic way to name any polygon that has more than 12 sides. So, a figure with 4 sides is called a quadrilateral. A figure with 5 sides is called a pentagon. 6 sides, hexagon. 7 sides, heptagon. 8 sides, octagon. 9 sides, nonagon. 10 sides, decagon. 12 sides, dodecagon. And then for any figure that has more than 12 sides, we're going to call it an n-gon. So if it had 20 sides, we would call it a 20gon. Or if it had 15 sides, it would be a 15gon. So here's our first example. Name the polygon, then classify the polygon by the number of sides and convex or concave. So to name a polygon, you're going to start at any vertex and you're going to list the letters in order. So you could have a different name than I do. I'm going to name this one Polygon JKLMN. Next, we need to name this by the number of sides. It has 5 sides, so it's going to be a pentagon. And finally, since this figure is not caving in, this is a convex polygon. Next example, draw a concave hexagon. Label all of the vertices, then name the polygon. So I want you to pause the video, try this on your own, and then play the video. You will probably have a different answer than I do, because there are millions of ways that you could name and label and draw a concave hexagon. So here's what I chose to draw. So here's my concave hexagon. It's concave because it caves in here and here. It has 6 sides, so it's a hexagon. Now I need to name the polygon, and I'm going to name it Polygon J Caden. Alright, classify each figure as convex or concave and by its number of sides. So the first one is going to be convex, and it has 1, 2, 3, 4, 5 sides. So it's a convex pentagon. The next one is not a polygon. The reason is because it has this curved side right here. Polygons cannot have round sides. They have to be straight lines connecting the vertices. And the last one. This one's concave because it caves in, and it has 1, 2, 3, 4, 5, 6, 7, 8, 9 sides, making it a concave nonagon. The final way that you can classify polygons is as regular or irregular polygons. Regular polygons are going to be equal angular and equilateral. Equal angular means all the angles are the same. Equilateral means that all the sides are the same. Irregular polygons are going to be the opposite of this. Irregular polygons are not equal angular and equilateral. So, classify the polygons as regular or irregular. So, how do we know if all the sides are the same? Well, they can all be labeled the same value, or you see these tick marks that we learned about, meaning that they're all congruent. So all the sides are congruent and angles are congruent on A, which makes it regular. On B, all the sides are not labeled the same, and we don't know if the angles are the same or not. So B is going to be irregular. So our answer is going to be B, that A is regular and B is irregular. Now for the second half of our notes, perimeter, area, and circumference. This should all be a review for you. You have already calculated perimeter, area, and circumference before. Alright, so perimeter is the distance around a figure, circumference is the distance around a circle, and area is the number of square units enclosed by a figure. So when we're looking at rectangles and squares, to find the perimeter, you're just going to add up all the sides. And to find the area, you're going to do area is equal to base times height. So for the green rectangle, all I need to do is add up all the sides to find the perimeter. I know the sides across from each other are going to be equal. That's how I knew this one was 4 and this one was 11. So the perimeter for this one's going to be 30 feet. Alright, area. Let's find the area of this square. I just do my base times my height. I do want you to notice that these are not in the same unit. You have to have them in the same unit in order to calculate area. So we're going to turn our yards into feet, and it's going to be 3 feet. So we're going to have 3 times 3, which will give us 9 feet squared. Now for triangles. Again, for perimeter, we're just adding up all the sides. So the perimeter of the triangle on the left is going to be 26 feet. Now for area, it's similar to the square, but it's going to be 1/2 base times height. Notice again that we do not have the same units here. You could either make this 1 yard or you could make this one 6 feet. I'm going to go ahead and make this one 6 feet so that they're in the same unit. So I have 1/2 times my base, which is 6, times my height, which is 3, which is going to give me 9 feet squared. The final figure we're going to talk about is circles. So circles have a little bit of vocabulary going with them. A line that goes straight through the center and touches the endpoints of the circle is going to be a diameter, and a line that goes from the center to the outside is going to be a radius. Remember, a radius is always 1/2 of a diameter. So instead of perimeter, we call a circle's perimeter circumference. There's two ways to find circumference. You can either do 2 times pi times r, or you can just do pi times diameter. This is because 2 times the radius equals diameter. So both of these formulas will work. To find the area, you're going to do pi times the radius squared. So find the circumference and area in terms of pi. Well, circumference is really easy when you're given diameter. We're just going to do the diameter times pi, so it's just going to be 12 pi since we're leaving it in terms of pi. Now for area, we have to use the radius. Our radius is going to be 6 because it's going to be half of the diameter. So our area is going to be 6 squared times pi, which is going to be 36 pi centimeters squared. Area is always squared whenever you're talking about the units. What if I'm given a figure like this? We don't have a formula to find the figure's area, because this is a really weird figure. So what you're going to do is you're going to break weird figures into pieces and add up the areas. So I want you to pause it and try this one on your own, and then I will show you the answer. So I broke it into a top rectangle, middle rectangle, and bottom rectangle. The top rectangle has an area of 45. The middle rectangle has an area of 10. And the bottom rectangle has an area of 50. When you add all of those together, you get the total area of 105. Our final example. Again, I want you to pause this and try it on your own, and then play the video and I'll show you the answer. Find the area of rectangle QRST with vertices at Q, which is 0, 0, R, 0, 5, S, 4, 5, and T, 4, 0. Well, anytime you're given points, you should always graph them on a graph. So I'm going to go ahead and graph my 4 points, and I can see that that forms a rectangle. Now to find the area, I need to know the lengths of these sides. No, you do not have to use the distance formula. Since these are vertical and horizontal lines, you can simply just count. So this side is 4 and this side is 5, which is going to give me an area of 20. We're going to skip this last example and we'll talk about it in class.